Okay, so welcome back to another video. Here today we have last year's Putnam Exam, and this is question A2. The question asks, for every positive real number x, let g of x equals the limit as r approaches 0 of x plus 1 to the power r plus 1, subtract x to the power r plus 1, all that quantity to the power 1 over r. And we are being asked to find the limit as x approaches infinity of g of x divided by x. Personally speaking, I think this is probably one of the easier Putnam Exam questions out of, at least from all the ones that I've, seen and encountered so far. Basically, typically because this is like a standard calculus problem, as you notice, I think straight off the bat, right away, you'll see that this is actually, you get an indeterminate form. And of course, with that, you would have to apply L'Hopital's rule to actually get a further achievement on how to, evaluate this limit. Now, of course, it's not in a form of L'Hopital's rule, but we can actually fix that up itself. And of course, after rewriting a simplified form for g of x, all we do is just plug this in and then, evaluate that limit itself. So pretty standard problem. I think that's, personally, I think it's easy. You guys think it's easy too. Let me know in the comments what you feel is the easiest Putnam Exam question that you've ever solved or ever encountered. Also, one more thing. So I popped my right pinky playing basketball earlier today. So yeah, this was pretty bad. It was painful. So I went to the doctors earlier today, and then they gave me this brace. I'll be on this for 2 weeks, hopefully speedy recovery. So you'll be seeing my right hand in this cast for future videos. Not for many, but a few of them. And it's also with that I'm also have to write a little slower just so I don't create myself even more pain than I already suffered from earlier. But hey, that's what it is. Basketball is life, just saying. Let me know if you guys play basketball. All right, let's just jump in. So straight off the bat, you'll see that if I were to plug r approaches infinity, r approaches 0, so we have that I have x plus 1 and then 0 plus 1, subtract 0 plus 1, and then all this quantity to the power 1 over 0, then of course we have that this is just x plus 1 to the power 1 and then minus x to the power 1. The x will cancel each other out, so we're left with 1. However, if we look at a 1 over 0, that's undefined. But if we're actually looking at it from the a positive real x and we're looking at it from the left side, you'll see that this is actually going to approach infinity. So in the form, we have a 1 over infinity indeterminate form. Also, worth noting that the next thing we're going to do is, if you pay attention that for r is greater than or equal to 0, if we actually look at just the inside expression of our, given limit, excluding this exponent, you'll notice that this inside expression is actually strictly greater than 0. So applying this, what we can do is we can actually take the natural log of both sides. So that means we have the natural log of g of x, then we set this equal to the limit as r approaches 0 of ln. Well, if we take the natural log, so that would mean I can actually move this 1 over r exponent to the front of our natural log. So that means we have a 1 over r, then times ln of, so it's the same expression on the inside. So x plus 1 to the power r plus 1, subtract x to the power r plus, or actually this is supposed to be minus 1. No, I was right. It's actually supposed to be r plus 1. Sorry about that. Then that means what I can do is, if we want to use L'Hopital's rule, so of course we have a 1 over r, so that means the r can just go under the denominator. So here we have the limit. So just all it is just moving the r into the denominator. So we have the natural log of the same expression, x plus 1 to the power r plus 1, subtract x to the power r plus 1. And then all this being divided by r. And of course, if you were to plug, take the limit as r approaches 0, we have a 0 over 0 indeterminate form. Therefore, we can actually take the limit, or not the limit, we can take the derivative of both the numerator and denominator, then take that limit again, and hopefully we actually get some finite value and not in another indeterminate form. But no worries, we see that the following given. So if I write the limit, r approaches 0, if we actually differentiate in respect to r, so let's see, the same thing, ln, then x plus 1, r plus 1, subtract x to the r plus 1. all this being divided by, we just take the derivative in respect to r. And so obviously we see that the denominator is just going to be 1, so that's fine. So we just have to take the derivative of the top over here. And we see that applying the, since we have a natural log, so we have a, take its derivative, it's a 1 divided by whatever the inside expression, then multiply with the derivative of the inside expression. And so we see that the following we have is the limit as r approaches 0. So just applying with that whole natural log derivative. So the following we have is x plus 1 to the power r plus 1, then multiply by ln of x plus 1. Then we can subtract with x to the power r plus 1, then multiply by ln of x. And then all this being divided by, because it's the 1 over with that derivative. So this will be, the inside expression is just x plus 1, then r plus 1, subtract with x to the power r plus 1. And so now all we do is just take the limit as r approaches 0. So we have a x plus 1 to the power 1, then multiply by ln of x plus 1, x to the power, so that'll be just 1, and then times ln of x. Now on the bottom, of course, actually it's just going to be the same thing. Like here, we know that actually is just going to approach 1, so that's neat and dandy over here. So now we have that the following is x plus 1, then times ln of x plus 1, subtract x times ln of x. So we said that that's equal to ln of g of x, but no worries, all we gotta do is just take the exponential base of both sides just to get our g of x by itself. So g of x is now equal to e to the power this entire expression over here. So x plus 1, then ln of x plus 1, then subtract x ln of x. So now we can actually rewrite the right-hand side a little further because we have the natural log of x. So if I fix this up a bit, so I can write this as a product of e basis, so x plus 1, then times ln of x plus 1. We have a minus, so this will be times e to the negative x ln of x. Then if we just rewrite everything and simplify stuff out, the natural log will just cancel. So it will actually, the following what we have is, and because x plus 1, we just move that as the exponent back in. So therefore we have a x plus 1 to the power x plus 1, all this being divided by x to the power x. So hence, therefore, we found what our g of x is simply reduced down to and simplified to. So g of x is simply just equal to this. So now all that's left is we just have to calculate the find the derivative of g of x over x as x approaches infinity. So let's actually finish this off. So let's write limit x approaches infinity. So that'll be g of x divided by x. So now we just plug this in. So the limit x approaches infinity. So just substitute the g of x in for here. So this is x plus 1 to the power x plus 1 divided by x to the power x. Then I can just write the divide by x as a 1 over x. So multiply by 1 over x. Then you can see that we can actually apply, with the exponent rules, they share the same base, so I could just add a 1. So now really this is the limit x approaches infinity. On the top, we would have a, so this is x plus 1 to the power x plus 1 on the top, and then the denominator is just x to the power x plus 1. Notice that they share the same exponent, so we can actually group this a little bit differently with the properties of exponents. So x approaches infinity, so the inside expression can be reduced to as x plus 1 divided by x, and then to the power x plus 1. And of course, using properties with, exponents, we can actually write this as a product of limits. So what we'll have, the following is, now we have a limit x approaches infinity. So I'm going to separate this out. We can also reduce this down, so we have x plus 1 over x. That's the same thing as 1 plus 1 over x. So I'm going to write it in that notation. So we have 1 plus 1 divided by x to the power x, and then we multiply this with the limit as x approaches infinity of 1 plus 1 divided by x. And you'll see that obviously the right expansion, that's just going to equal 1 since we have a 1 over infinity. So it's that'll tend towards 0. So that's 0 over here. Over here, you'll notice that this is actually this is the limit definition of e. This is supposed to be 1. Sorry about that. So that's 1 over here. And so therefore we have a e times 1. And so therefore the limit as x approaches infinity of g of x divided by x is equal to just e. And just like that, we are done with this simple limit calculation. Again, I feel that this is actually one of the easier Putnam Exam questions. Personally, for me, you just let me know if you find something that you feel it's easier to compute all this following. So yeah, that's pretty cool if you ask me.